So we're going to look at some statistics, and we're going to see here that X and Y follow a bivariate normal distribution. Now all that means that X and Y are both individual random variables, and they both follow a normal distribution. And here we're going to try and combine something with the two random variables. And what we're actually looking for is to find a conditional distribution of Y given that X equals X. So how are we going to go about doing that? Well, we're given some parameters here that we already know about the two distributions. So mu of X, that's the mean of the distribution of X, is at 0. And likewise for Y, mu of Y equals 0, obviously mu being the Greek letter. And sigma squared of X, that's the variance of the random variable X, is 9, i.e. the standard deviation would be 3. And here we've got the variance of Y is 16. Just put that little tail on the top. So again, sigma, the Greek letter. And the correlation between X and Y is valued at 3/4. And that's also given by the Greek letter rho. Now it looks like a P, but it's actually rho. So that's RHO. I'll just write that here for you so you can see that. So that's the Greek letter rho. Okay, so we've got a conditional distribution Y given that X equals X. So we're given a value for X. So a normal distribution will give us N. We'll write that as an N. And then we give the mean first, so that's mu, and then sigma squared, which is the variance. Now that's quite an accepted way of writing a normal distribution, but we're looking for something different here. We're looking for a conditional distribution. So the way we go about that is that Y given X equals X, the distribution for that is written as N, again signifying normal distribution, and then we start off with the mean of the random variable Y, because that's our one that we've got first. So if it was X given Y equals Y, we want the mean of Y of X here. And then now we've got a little combination here using the correlation. So we use the Greek letter rho, and then we're going to multiply that by the standard deviation of Y divided by the standard deviation of X. So that takes care of that. And then with that, we need X minus the mean of X. And then that takes care of our mean for the conditional distribution. And then what we need now is our variance. So our variance now is the variance of our Y with 1 minus rho squared is what we'll multiply this thing by. Okay, and then we just bracket that off. So now it's just a simple case of carefully plugging in the numbers, and then that's going to give us our distribution. So let's see where that takes us. So our distribution is N. So mu of Y is given as 0. Rho is 3/4. Now we need the standard deviation of Y divided by the standard deviation of X. Well, sigma of Y, so I'll just write that down here. Sigma of Y, that's the square root of 9. And sigma of X, sorry, the other way around. Sigma of X is a square root of 9. And sigma of Y, standard deviation, is the square root of 16. So these we can easily calculate what they are, that's fine. So now I can plug in my values here for Y and X. So now I've got 4 divided by 3. And then I've got X minus, so X is the random variable value that we're assigned. So that just stays as an X. and then we subtract the mean of x, which is 0. So that's going to take care of the mean of this conditional distribution. Now we need the variance. So sigma squared of y, that gives us 16. And now we've got to multiply this by something. 1 minus p squared. So it's like 1 minus rho squared. So 1 minus rho squared, that's 3/4 squared. Okay. So now it's just a case of just simplifying these numbers off. So now we've got normal distribution, 0 plus 3/4 times 4/3. Well, that's just going to give us 12/12, which we can simplify in a minute down to 1. X minus 0 just gives us x. So that's going to give us our mean. And then we've got 16 times 1 minus 3/4 squared. So 16 times 1 minus 3/4 squared is going to give us 9/16. And that takes care of that. Okay, now we can simplify even more. So 12/12 cancels to give us 1. So that's just going to leave us with 0 plus 1 times x, which is going to leave us with x. This one is going to be a little bit more complicated, but I'm sure we can get there. So we change this 1 to 16/16. So now we've got 1 minus 9/16 will give us now 7/16. So that's what we'll have so far. But then we multiply by 16 and these two will cancel out. So therefore we're going to get just 7. And there we go. So now we've got our conditional distribution for when y given x equals x is distributed x with the variance at 7. Okay.